from the chemical test, we are going to continue with the test for cation. First of all, what is cation? Raise your hands. The difference between cation and anion. Mm, anyone else except Mariam? Yes.
Miss, cations are positively charged ions. They are atoms that form positive charge, and anions are the atoms that form negative ions.
Okay. So cations are those which will be having positive charge, anions are those which are going to have negative charge. So cations and anions, which are going to form from metals, which are going to form from non-metals. Yes, Luna?
Yes, Miss, again? I couldn't hear you.
Anion and cation, which one is forming from metal, which one is forming from non-metals?
For the cation, as we got from Mariam, that it has positive charge. So I guess it will be a metal.
Hmm.
And for the it will be non-metal, as it's always
Anions
negative.
are going to be non-metal. Okay, fine. So yes, the cations are basically the positively charged ions formed mainly from the metals by loss of electron, except some of the complex ions which will be having a different structure, not the metal. If they are simple one atom, it is going to be metal. For the complex ion, that is different. Okay. So yes, if we want to test the cations, for all the cations, there is only one single test that you need to remember, and it's very easy. Just add sodium hydroxide and see what color you are getting at the end. That's it. Whatever cation is over there, you want to see what cation is there, maybe copper, iron, Fe+2, maybe Fe+3, maybe ammonium. Whatever cation you want to check, what you have to do? Add sodium hydroxide. As soon as you are going to add sodium hydroxide in the solution of metal, metal ion means what? Aqueous solution. In the form of solution, we are taking only then it is going to be iron. Okay, not the solid metal. We are taking solution of the metal, aqueous solution. So we are adding sodium hydroxide in the solution. As soon as you add the sodium hydroxide in the solution, it is going to make the final thing precipitate. This sodium will replace, okay, and we are going to get the metal hydroxide precipitate at the end, and that precipitate will have some color. Okay, so you will remember some of the colors. For example, for the copper, it is going to be light blue precipitate. Iron Fe+2 will be green. Fe+3 is going to be brown in color. Okay, so these colors you will remember. This is very important. In the exam, they can ask you for the iron 2 and iron 3. Iron 2 will be green in color. Iron 3 will be brown precipitate. No, don't write the green solution or brown solution. It will be wrong. Okay, this question can come in 2 marks as well, one for the color, one for the state. All are going to basically be precipitates, means the solid form. Same for the ammonium. What ammonium is going to do? Whenever we have ammonium somewhere, ammonium means it is going to have ammonia gas inside. It means we can use the test for ammonia gas. As soon as you're going to add sodium hydroxide, ammonia gas is going to produce. And we did this in one of the class as well, how to test ammonia gas. We can use the litmus paper. Red litmus paper will turn blue. It means that is the confirmation of ammonia gas presence. Okay. So this is going to be the simple test for the cation. For cation, it's easy because it is only one thing to add, sodium hydroxide. See the color, final color for the precipitate, and you will be done. Okay, I will take your questions after that, just 1 minute. Okay, there is one problem in this one, and that is sometimes you will not be able to see much of the precipitate or color. Like it will be little hard to identify because you will not be able to see much of the precipitate formation. And the reason is why it will be less, because maybe the cation present is very small in quantity. So it is giving very less precipitate at the end. Okay. So then what you can do, if you just get a slight cloudiness, some of the precipitate formation, it means there is cation present. You can just confirm the cation. If you're not getting much of the precipitate, it's okay. Even a small indication, a small formation of the precipitate will tell you the cation presence. It means the reason is because there is small quantity of cation over there, which is giving
Miss,
you
can
giving you the less precipitates. Now your questions from this. Yes.
Miss, can it also be the reason that because of the light blue color, it might not be seen? Or is it precipitate? They're solid, so they make it cloudy, so it can be seen.
We will be
That's
able to see the color. We will be able to see the color, but it will be light color or maybe very less precipitates. Precipitate means you will be able to see solid clearly in the solution. If you are not able
oh,
to see most of the solid, only few uh, crystals or only few precipitates you can see, it means still it's the formation of the
mm.
precipitate. Okay,
So
color will be,
Miss,
you will be able to see the color. But if you don't have enough precipitates, a small quantity of the precipitate is also going to confirm you the positive test result. It means
so
there
Miss,
is cation present in the solution.
so it might be light blue, white color, something like that.
Light blue color,
White.
not no. White is not going to be copper. Light blue for the copper, green for the iron, like this. You have to confirm the color very carefully because they can give you unknown solution and they can ask you to identify, or maybe how the question can come, they can ask you, okay, you have an unknown solution, we don't know whatever is the metal inside. If you add sodium hydroxide, it is giving you brown precipitate. What can be the cation? It means it is going to be iron 3. If you add sodium hydroxide, it produces bubbles. What can be the cation? Only one cation, NH4 positive, is producing ammonia gas, which will give bubbles. So it means ammonium ion is there.
Miss, one question. What is the
Hmm.
difference between iron 2 and iron 3? Is it the charge?
Iron 2 has lost 2 electrons from the metal iron.
Yes.
Iron 3 means it is the loss of 3 electron. Okay.
Okay.
When it loses 2 electron, it has a different color. 3 electron, it has a different color. It is one of the transition element. Anyone remember? Anyone can tell me why iron is losing 2 or 3 electrons from the transition metal chapter?
Miss, because it has more than one oxidation state.
Very good. It
Oxidation.
has more than one oxidation states. Transition metal has the property they can lose more than 2, 3, 4, 5 different electrons to have different
Oh,
positive charge.
yeah, I remember now.
And
Yeah,
all
yeah, I
those
remember.
will have different color as well. Okay, when they're losing different electron, they're giving different color at the end. Okay.
Okay.
Any other question here? Some of you are raising hand. Yes.
Yes, miss. For iron 2 plus, if we write it instead of writing it as a symbol, if we write it in words, so it would be iron and 2 in parentheses, right? Like 2 in
Iron and 2 in
brackets.
the bracket. And for this one, it is
Yeah,
going to be iron
iron
and
and 3 in brackets.
3 in the bracket. That is
Okay.
the writing method we use. We have transition elements with more than one oxidation state.
So,
Okay.
Miss, I
You
most
have
of the
question as well? 1 second. No,
Miss.
no.
Oh, okay. Yes, sure.
Jude, Jana, you're raising hand. If you have any question, you can ask.
Yes,
Miss.
Miss, I have a question about the cathode and the anode. I don't understand how isn't cathode and the anode is in the electrolysis? How is it a metal? Yeah,
Cation, no. Electrolysis
cathode.
means what? We are going to break the ionic compound into positive and negative ions. That was a different
Yes,
method. Now, let's say you have copper or nitrate. Okay, what is going to be the formula for copper nitrate? Or maybe you can take any other. Let's say you take one of the negative ion. I'm going to use the same that we have over here. Let's say you have copper sulfate, the negative ion. Copper is going to be +2, sulfate is going to be -2. So you have copper sulfate. This is one of the unknown solution. You don't know the name of the solution. I'm giving you a beaker having copper sulfate solution, but I'm not telling you it's copper sulfate. I'm asking you, do the test on this solution and identify whatever is metal positive ion, whatever is negative ion. So you will perform the test to identify is it copper or any other metal inside, and then you will perform the test to see if it is going to be sulfate or anything else. So like this, any unknown solution will be there. You can perform the test to identify the positive part of the formula. Then you can perform the test to identify the negative part of the formula. So to
Okay, so we
identify the positive part of the formula, you will be adding sodium hydroxide. See the colors. If I give you this unknown solution, it will definitely give you light blue precipitate when you are adding sodium hydroxide. It means copper is there.
okay, yeah.
Then you will do another test to confirm the negative ion for the sulfate that we will do just now. Okay. So
Okay,
like this, any unknown solution having some positive negative ion inside, we can do the cation anion test to confirm which positive negative ion is present. Okay.
okay, Miss.
Okay. Now let's
Yes.
move towards the anions. Only
I
few of
have
the
a question.
anions you have to remember. Yes, your question.
Miss, I don't really understand what are we يعني, trying to find.
What we are trying to find. See, what I said, let's say you have an unknown solution, you don't know the name of the solution. I'm giving you a beaker, having some solution, you don't know what is inside. I just told you that it is going to be an ionic solution. Means there is some positive thing and there is some negative thing in the solution. Do the test, identify. Okay, so you will do the test for the positive ion first of all to see which positive ion is there. Then you will do the test for the negative ion to identify the negative ion, and then you can easily write the formula.
Okay, Miss, but if we reacted here copper and sodium hydroxide, the copper will not react.
The copper will give the light blue precipitate.
Yes,
Okay.
so we want to
If you
know
add sodium
the
hydroxide,
solution, right?
this copper is going to give you light blue precipitates over here.
So what does يعني have to tell us about the solution?
You no need to tell about the solution. That is the reason I'm not giving you the equation over here. They will not ask you to write the equation, whatever is happening, whatever is the replacement reaction or what. No, only color change you need to tell. That as soon as you add sodium hydroxide, if copper is there, you will get light blue precipitate. That's it.
Yes, so
No
we want to know
write any equation
which
for this.
metals are present in the solution.
What ions are present in the solution? That's what we want to identify.
Okay,
So one
thank you.
positive ion, one negative ion is there. So we want to identify which positive, which negative is in the solution. Okay. Yes, Varif.
Miss, can you hear me?
Yes, Varif.
Miss, my question is that the testing of cation and anion are the same? Like we're gonna do the same? Or
No,
if there's some
not
difference?
same. For the cation, we are adding sodium hydroxide. For the anion, it's different.
Oh,
Okay. So let's move towards the anion. Only some of the anions you need to check. Let's say they can ask you about the carbonate, how to confirm if carbonate is there or no. How to confirm halide. Halide means from the halogens, chlorine, bromine, iodine with the negative charge. So we say them chloride, bromide, iodide when they have negative charge. Or you can check about the sulfate ion. That's it. No other negative ion, not nitrate, not other negative ions. Only these will come in the exam. Okay. So for the anions, you need to remember more steps because all the anions have a different test. If you have any doubt that let's say carbonate is there or no, if you want to check the carbonate, test is different. If you want to see if the halide is there, maybe chloride, bromide, iodide, test is different. If you want to confirm sulfate, test is different. Okay. For all the anions, the test is different, but for the cations, test was only one, adding sodium hydroxide, same. Okay, now let's see the anions one by one. If you want to confirm if the carbonate is there or no, carbonate means CO3 with 2 negative. So what you have to do, take the carbonate solution, add acid in it. We did this already. When the acid and metal carbonates react, they produce Carbon dioxide gas. So bubbles of the gas we can easily see. Bubbles will be produced. But if you want to see if it is actually carbon dioxide, you can do the lime water test that we did in carbon dioxide gas test. Pass the gas from the lime water. If the lime water will turn cloudy, it means it is going to be carbon dioxide gas. So your observation will be, you can see fizzing, you can see effervescence, or you can say that we can see the bubbles of the gas. So this is going to
Miss,
be the test for the carbonate. So step number 1, add acid. Dilute form of the acid is fine. No need of the concentrated acid. Bubbles of the gas will produce. Confirm the gas by passing it from the lime water. If the lime water will turn cloudy or milky, it means that is carbon dioxide. It means there is carbonate ion present. For this, now you need
Miss.
equation as well. Yes.
So we use what was it called? Calcium hydroxide, which is another form of lime water.
Yes, lime water is
But
basically calcium hydroxide. Yes. Okay. First, we are taking the carbonate. Carbonate means metal carbonate, so CO3 to negative. We are adding dilute acid. Acid is providing H positive. So carbonate and H positive will react. They make carbon dioxide and water. Okay. Then this carbon dioxide we are passing from the lime water. Lime water means calcium hydroxide in the aqueous form. If carbon dioxide is there, it will react with the calcium hydroxide and make calcium carbonate. And I hope you remember calcium carbonate is solid. Precipitate will be there. That precipitate is making the solution cloudy or milky. Okay, so white precipitate of this calcium carbonate will be visible to us, which is confirming that carbon dioxide is there. Carbon dioxide is confirming that the starting anion was carbonate. Okay, yes, Jude.
Yes, Miss, I actually had a question from the one before about the iron, the Fe. So why is the color different for both of them? What makes the color different? Why isn't it the
The
same?
electron loss. If you lose different electrons from the metal, color will be different. This one we did in the transition metal chapter. The transition metals have the property to lose different number of electrons, give different oxidation states. And all the oxidation states have different colors from each other. Their shell number changes, their electron configuration will be different, so their colors will be different. Okay. Any other
Miss, your
questions?
voice cut out. Your voice
Hmm.
cut out in the middle.
Okay, so basically I'm telling that in the transition elements, we said that the transition metals have the property to lose different number of electrons and to have different oxidation states. So different loss of electron means shell number will be different, electronic configuration will be different, means their color will change, properties will change. Now these two
yes, Miss.
irons have different properties, little different reactions, different colors because their electronic configuration is different now.
Miss, yes, their chemical properties and physical properties are changed.
Changed, properties will change.
So, Miss, for example, if there's a question to write an equation or something, how can we know if it's iron 2 or iron 3?
Let's take an example. We took this
Depending on the color.
FeCl2, FeCl3. Both are iron chloride. Okay. Can you see which one is iron 2, which one is iron 3? What is the oxidation state or the charge on the chlorine? -1. Yes, Jude, you want to answer it? Or anyone?
Miss, may I answer?
Tamreen?
If
One
Oh.
sec.
As for FeCl2, the charge on Fe will be 2 plus, and the FeCl3, the Fe will be 3 plus.
Right. Every chlorine is -1 because it is from the group 7. It can take 1 electron to become -1. 2 chlorine means 2 chlorines will be -2. To make the whole thing neutral means Fe will have +2 charge. So
And
this
Miss, we
Fe
also learned the
plus
swap
2.
and drop method.
In this
How to
chlorine, it is basically -3, 3 chlorines. It means now this Fe is +3. So this formula you will write iron 2 chloride. This is iron 3 chloride. So their colors, their properties will be different. Both iron chlorides will be different now.
Okay, miss.
Okay. So like this, when we have transition elements, they're going to have different oxidation states, different colors. If we just write iron chloride, you will not be able to see if it is this formula or this formula. You have to mention in the formula it's iron 2 or iron 3. Only then you will be able to get the right formula at the end. Okay. Okay, let's go back to the carbonate.
Miss, can I
Carbonate
ask?
test is done. Any question from this carbonate test? Anyone? Raise your hand quickly. Okay. No question, then we can move forward.
Miss, I have a question.
Yes, say.
Miss,
Summary.
for the carbonate, why is it reacting with hydrogen?
Hydrogen is coming from the acid. Basically, we are writing ionic equation. We are not writing the full equation. Okay?
Okay.
That is the reason we are not writing over here salt. If you write the full equation, it should be metal carbonate with HCl, making a salt, carbon dioxide, and water. 3 products, right? So
Hmm.
they are not writing the metal, so they are not writing the chlorine, and they are not writing the salt.
Because
Why?
they're not won't react
Because
or
it
they
is not
won't form.
reacting, it is spectator ions. If you write the ionic equation from here, the metal and chlorine will just cut with the metal and chlorine from the salt, and only this will be left as a final ionic equation. So they're writing the final ionic equation after cutting the spectator ions, which are not participating in the reaction.
Okay. And Miss, one
Okay.
more question. Miss, the
Yes, sure.
precipitate is the solid formed when in a chemical reaction, right?
This product, after passing it from the lime water, is going to be the solid, the calcium carbonate.
So Miss, that's the precipitate.
What you said again, Samreen?
Miss, the precipitate is the solid we get from a chemical reaction.
Yes, if you write, see, if you're going to write in the exam insoluble solid, okay. Or if you write precipitate, precipitate means insoluble salt. So then no need to say insoluble precipitate. No, no. Precipitate means insoluble solid. So just say that precipitate is going to form for calcium carbonate. Means insoluble salt is forming. So
Okay, Miss.
insoluble salt is forming in water, so there will be cloudy solution just like this. First of all, it is going to be a clear solution. Carbon dioxide is passing, so it is making the solution cloudy. So precipitates are there in the water. Yes, Wafia.
Miss, the spectator ion thing got me confused again, I think. So, in a regular equation, how do we find out which ions are the reacting ions and which ones are the spectator ions?
See, for example, if you're writing any equation, here we can take any carbonate. Let's go to the reactivity series and see. Let's say we take sodium carbonate. Okay, that is basically the ionic topic, ionic bonding when we did. Let's say I'm taking sodium carbonate, Na2CO3, which is soluble salt, aqueous. I'm taking HCl, also aqueous. It means it is going to make NaCl, aqueous. It is going to make carbon dioxide, gas, and then it is going to make water, liquid. I'm not going to balance the equation, just giving you an idea. Later on, you can balance it as well. Okay. Now, to get an ionic equation, we said that we are going to break only those species into ions which are aqueous. Means we can break Na2CO3, HCl, NaCl, that's it. Na2CO3 is giving you positive Na2, two Nas are there, so two Na positive ions will be there in the form of aqueous. Carbonate means CO3, two negative in the form of aqueous will be there, right? Okay, if we balance the equation, first of all, it will be easy to see. How we can balance it? We have two hydrogens over here. What we can do? We can put 2 with HCl, right? Then we have 2 sodium, 2 chlorine, we can put 2 over here. Okay, now this is going to be the balanced equation. Then you can break HCl into ions. There are 2 hydrogens. So 2 hydrogens in the form of positive, aqueous will be there. 2 chlorines in the form of negative, aqueous will be there. what I'm doing, I'm just splitting aqueous thing into its positive and negative ions to make ionic equation. Then on the other side, the NaCl is going to break 2 Na separate, positive ion aqueous, 2 Cl separate, negative ion aqueous, and the carbon dioxide and water is not going to break because they are not aqueous. Only aqueous thing can go into the ions. Now we have to cancel out the same thing on both sides. If you check out, we can cancel what thing? Just tell me quickly. Which is same on both sides. Same state, same formula.
Miss
So
Josie, sodium
sodium,
chloride.
Sodium and
chlorine.
Sodium.
chloride. So those
Yeah, that's
species
it.
ions which we are cutting on both sides, it means they are not participating in the reaction. In other words, they are not changing when they are going to product side. They're same when they're going to product side. So
Oh,
these
okay.
ions are
Yeah,
known
now I
as
get it.
spectator ions.
Oh,
They are not participating in the reaction. So they are spectator ions. So that is the reason,
Miss, just like
we are
Miss,
not going to mention these spectator ions in the equation. Now this carbonate, H positive, carbon dioxide and water is going to give you the remaining ionic equation. So they are not writing the spectator ions over here. They're just cutting them because they're not participating in the reaction. And remaining ions will be there in the final equation. Okay, this is clear now. So carbonate and H positive from the reactant side, carbon dioxide and water from the product side will be there in the ionic equation. Okay. After
it's
that,
just like on in the ionic equation that we took for neutralization,
yes, we
which
did
is
this already. We did
yeah,
how to
yeah,
write the spectator ions and how to cut them on both sides of the equation to get the
which we
final
took
ionic equation.
sodium chloride plus
Hmm.
the products we took sodium
Right.
chloride and water is the ionic equation. The sodium chloride are the spectators.
Yes. So those who are going to cut on both sides, that is going to be spectator ions. Okay, let's move after that to another test for the halide ion. Before that, if you're going to mention your result for the carbonate, be very careful to use the right words. If you're going to just say that lime water turns cloudy, this is not giving you full marks. This will not be enough information. You will say that if you pass the gas, lime water will cloudy, it means there is carbonate ion present. So write the complete statement whenever you are going to write the positive result. Okay. Okay. For the halide ion test, we are going to do 3 steps. Number 1, we are going to add nitric acid to make the solution acidic. It has a purpose, I will tell you. And then we are going to add silver nitrate solution. And then what will happen? You will get a precipitate at the end. Color of the precipitate will tell you which halide is there. Before I tell you the detail why we are adding the acid or the silver nitrate, just let me tell you the color first of all. You will get 3 different colors. If coloride will be there, the final precipitate color is going to be white. You will get a white precipitate. If bromide is there, then you will get cream precipitates at the end. If iodide will be there, you will get yellow precipitates at the end of the solution. That will confirm you which halide is there. Okay. Now, why we are adding nitric acid over here? We are adding nitric acid first of all to provide the acidic medium for a good reaction. Second thing we did in one of the file as well, we add the acid to remove impurities so that no extra carbonate or anything can participate in the reaction. Okay, so this acid is not directly involved in the equation. It is just extra addition to make the solution acidic for a good reaction and to remove impurities. Okay, the reason is written after that. I will show you. Why we are adding the silver nitrate? We are adding the silver nitrate solution to the metal chloride, whatever we have, so that they can have replacement reaction and they give you the metal nitrate at the end. Sorry, they give you the silver chloride at the end basically. metal nitrate and silver chloride. Two things will be there. So the color that you are going to see is for the silver chloride. White precipitate of the silver chloride will be formed. This metal nitrate is going to be soluble one, aqueous, so it is not giving you precipitates. Silver chloride formation over here is going to be a precipitate. That will be white precipitate over here. So state symbol solid we have to write with the formula. Okay. Yes, Jude, your question.
Miss, why is it specifically silver? Can't it be any other, element?
We need silver so that we can get the final thing precipitate. We can change it as well if we are getting a precipitate at the end. But that will be hard to remember which we can use. So there is a specific thing. Use always silver nitrate solution because it will work for all the halides. It will give you the insoluble insoluble solid or precipitate at the end with all. Okay. So that is the reason we are going to make it specific. Yes, Mariam.
Miss, I have a question. How can silver here replace potassium in chloride? And calcium chloride is formed and silver nitrate. So how can
Potassium is going to
silver?
replace silver, so silver is just taking its place. Other way around.
Mm.
Okay.
So the potassium is more reactive than silver.
So chlorine will be separate, so silver will just go and react with chlorine.
So, Miss, this is a double displacement reaction.
This is also a double displacement reaction, and you can see two soluble salts are giving you one insoluble salt. So yes, it is a precipitation reaction or double displacement reaction. Okay. So if you have same way bromide, in case of the bromide, same equation will happen. You can write the same equation, and the color for the silver bromide over here is going to be cream precipitate. And then for the silver iodide, it is going to be yellow precipitate. So reactants are same, like silver nitrate you have to add in all, and you will be getting 3 different precipitate colors, which will confirm you the halide ion. So this will be white precipitate, cream precipitate, or yellow precipitate. Yes, Jude, your question?
Oh no, Miss, I just forgot to lower my hand.
Okay, yes, Wafia?
Miss, they only gave us 3 examples, chlorine, bromine, and iodine, right?
And
So,
only included in your syllabus. That's it.
oh, but like hypothetically, couldn't like astatine and fluorine
Astatine
have
is
a halide test as well?
not important, so we don't consider it in the reactions when we are talking about. Okay.
Oh, okay.
And yeah, only these 3 are included because they are moderate reactive and they are good to see the colors.
Miss, we should be thankful for what we are given. خلاص, alhamdulillah. Okay, this one.
Okay, so here it's written that when we are doing the acidification step, means when we are adding acid, the halide ion test must be done with the nitric acid, not hydrochloric acid. Okay, we are
It's
using
because
nitric.
the hydrochloric acid is more reactive than nitric acid.
No. That's fine. Reactivity is not a problem. If we are using the hydrochloric acid, the chlorine will be there, chloride. It means it is going to interfere with this equation specifically. Okay. So we can use hydrochloric acid, maybe in silver, in bromide and iodide ion test, we can use hydrochloric acid, not a problem. But when we are testing for chloride, we don't need to use the hydrochloric acid because hydrochloric acid will also give chloride that will interfere or react with the main reaction. So we will not be able to get the right result. Okay. So that is the reason when we are going to do test specifically for the chloride ion, we are not going to use hydrochloric acid. So it's better to use nitric for all, the same thing. So it's easy to remember. Okay. After that, yes, any question here, Wafia?
Oh no, sorry, Miss, forgot to lower my hand.
Yes, Samreen?
Here in the exam that tip that is saying that the nitric acid should be used rather than the hydrochloric acid, and it's also saying that the chloride ions would specifically interfere with the result. Is that right?
Yes, if you're going to write that we are going to use nitric acid, not the hydrochloric acid, because hydrochloric acid also has chloride ion inside. So it will interfere with the result, so we will not be able to see the right result. So we should use an acid which is not going to have any common ion. It's different, so that we get the exact result.
Okay,
Okay.
miss.
Yes, Mariam?
Miss, if we use sulfates, can you go up 1 minute?
Yes, we are doing the sulfate. Just 1 minute.
So, Miss, it will produce the same thing, but with sulfates, right?
For the sulfate, now if you want to confirm the sulfate, we are going to have again 3 steps. Number 1, we can add dilute acid. Now you can use hydrochloric acid, not a problem. And then we are going to add a few drops of barium chloride solution. Remember it? There are many other options, but specifically we need to remember this. Add barium chloride solution. White precipitate of barium sulfate will be produced at the end, and
Miss, I have
that
a
is the
question.
information that sulfate is there. Okay?
Miss,
Same 3 steps you have to remember. Number 1, add dilute hydrochloric acid, then add barium chloride solution. So, you are going to get at the end a white precipitate of the barium sulfate, which is going to confirm you that the sulfate is there. In place of the barium chloride, they said you can even use barium nitrate, not a problem. Both will work the same way. Both will give you white precipitate of the barium sulfate at the end. In case of the acid, you can use any other acid as well. Maybe sulfuric acid or any other
Miss, I have,
acid. Yes, Wafia.
Miss, I have,
And then Luna.
Miss. Oh, so Wafia first? Okay. Do you have a question, Wafia?
Miss? Yeah,
Hmm.
2 questions, Miss. First one is that we only have the barium sulfate test in our syllabus.
Only the sulfate test, not barium sulfate. Yes, Mariam.
Miss, you said before that we can't use the chloride because it is common يعني, in the hydrochloric acid and in the other one. So here we used the chloride with hydrochloric
Yes,
acid
we
and
are not
again
using the hydrochloric acid in case of the chloride ion test. Because hydrochloric acid has chloride and chloride solution also has chloride, so it's common. Right? Same way, we will not be able to use sulfuric acid over here. Why? Because sulfuric acid will have sulfate, and this solution that we are checking also have sulfate because we are checking the presence of sulfate. So if there is any common ion, then that acid we will not be able to use. So
So
here
you
we can
can't use
use
the
other
common ion
acid.
between the acid and the thing that you are putting.
Yes, if there is any common ion in the acid, we will not use it because that common ion will interfere in the reaction. Yes, Wafia.
So, Miss, we could have some or any other element in place of barium here, right? Or is it just specifically for barium?
Yes, it can be any other having sulfate. Basically, we are confirming the presence of sulfate over here. But barium is basically, we are taking barium chloride or barium nitrate. Why? Because this barium with the sulfate will basically make the insoluble solid or precipitate that we need. So if you can use any other element over here which is giving you final thing precipitate, you can change. But that will make you confused that which other element we can use. So it's better to remember only one which is given. Barium chloride or maybe barium nitrate. That's it. Because it is for sure will make precipitate at the end.
Miss?
Yes, Luna.
Yes, fine. Miss, do we specifically use dilute hydrochloric acid or can it be concentrated or just dilute?
In place of the dilute hydrochloric acid, you can use any other acid as well. No problem. But except sulfuric acid. Because sulfuric acid will have sulfate. And sulfate is already there in the solution that we are testing. So common ion. Common ion means there will be problem in the reaction.
Miss, I
So
must
except
buy
sulfuric acid, you can use any other acid, maybe diluted form, maybe concentrated, not a problem. Why we prefer the diluted form? If diluted form is okay, no need to use the concentrated form of the acid.
Oh, okay.
So that is the reason if diluted can give us the result, no need to use the dangerous concentrated form of the acid.
So it depends on the mood. If it works, it works. If it doesn't work, it doesn't
No.
work.
If it will be reacting in the presence of acid, it will just react. Then there is no need of something concentrated. Concentrated we need when something is not reacting with dilute form. Extreme cases, then we use concentrated form. Okay?
So, Miss, basically,
Hmm.
Miss, so basically, we use two things: hydrochloric acid and barium chloride solution.
Yes, that's it. End of the story. It will be easy to remember. Use hydrochloric acid, then add maybe barium chloride or maybe barium nitrate. It will give you white precipitate of the barium sulfate at the end. It means there is sulfate present. Confirmation. Okay. Otherwise, when you will go to your grade 11, you will see that this is not the only test you can use. Barium chloride or barium nitrate is not the only thing you can use. Hydrochloric acid is not the only acid you can use. You have many possibilities. But for now, rather than writing another possibility and maybe writing little wrong, it's better to just remember this specific thing. Okay? And then later on, you can have more and more possibilities in your higher grades.
I'm thankful for what I have.
Okay, so then we are using the HCl hydrochloric acid over here. And as I told you, to make the reaction more reactive, feasible, and also to remove impurities such as carbonate or other impurities. So we are providing acidic medium, we are adding acid over here. Otherwise, acid is not participating in the reaction. It's barium chloride and the sulfate in the solution which is reacting. Acid is not reacting over here.